How do you do, ladies and gentlemen, and men and women and people and others? I am Julius Sumner Miller, Professor Julius Sumner Miller. And professor of what? Our business is physics. And physics is what? Physics, I suppose I would say, is what physicists do. And somebody says, now, Professor, that is circular thinking. Physics is what physicists do. Sure, what does a carpenter do? He does carpentering. And what do physicists do? They explore how nature behaves. So I left you last time with an inquiry of a common sort, but one which many, many, many get wrong. We are to imagine that I have two identical vessels, one filled with milk and one with cream. They are now, you see, empty vessels. How many see that? Oh, those of you who said they are empty. No, that is not right. They have air in them. They are not empty. I will show you later that I can't have an empty vessel. Never have an empty vessel. Not on the earth. Maybe on the moon. You follow me, all right. So the question is, one filled with milk and one with cream, and which is the heavier? How many agree that the cream is the heavier? How many agree that the milk is the heavier? Those of you who said that the cream is heavier will have to be sent to the seventh layer of some place named by Dante, because the cream is not heavier. The milk is the heavier. Cream is oil, and oil is lighter than water. And I know why you said the cream is heavier, because it is thick and viscous and sluggish. And furthermore, those of you who are too young have lived only in the age of homogenization, and you have never seen an old-fashioned quart of milk with the cream on top.
The professor is certainly clever, but me, yay!
So those of you who said the cream is heavier, down, I say. The milk is heavier. I think that's wonderful. More now on Mr. Newton and the first law. A body at rest wishes to remain at rest, or if moving uniformly in a straight line, that's what it wants to do. And look how wonderfully simply I can demonstrate that. We will imagine that this is a heavy hammerhead, heavy, like a sledgehammer. And here is the handle which I lodge in it, and it's held by friction. Now, how can I put that handle into that head further? Just like this. Hold it so the head has large inertia. I hit so, and the head has the handle driven into it. Case one. Case two. Let me start all over. I lodge the head on the handle ever so, and now I do as follows. Bang. What happens now? The motion of the handle is brought to rest by engaging the table. The head was also moving, but when the handle stopped, what did the head do? It kept moving. And so this is a wonderful demonstration of Newton's first law, which I say has two parts, not usually delineated. A body at rest wishes to remain at rest, or if moving uniformly in a straight line, wants to do that.